11.7 million people die each year worldwide due to cardiac arrest, according to the World Health Organization. The most important immediate care that can help in saving a person is cardiopulmonary resuscitation, also known as CPR. In the US, only 40% of the people who get cardiac arrest are given CPR outside of a hospital. There are 3 factors to keep in mind when doing CPR. The compression has to be at a very high pressure. You must push at a rate of 100 or 120 times per minute, and the chest has to move 5 centimeters down. Of the people who know how to do CPR, only a third can correctly perform it, according to a leading medical journal. My research shows that there are several CPR simulators you can buy, but I noticed most simulators have some drawbacks. The price ranges from $800 to $60,000, and low-end simulators do not teach all of the required skills. Also, in many developing nations, they cannot afford such expensive mannequins, and hence a low-cost simulator can make a great impact. So I developed a new CPR simulator that is a cost about $50. I called it IVES. IVES is based on an Arduino microcontroller. I designed a circuit that consisted of a buzzer, an LCD display, and a force sensor. The force sensor is underneath soft material that has bands of rubber on top that gives tension and recoils like a human's chest would. I created a computer program that measures the amount of times the user correctly pushes the chest of the mannequin. I also developed an algorithm that told whether the user passed or failed. My CPR simulator is portable since it uses a battery and does not need to be plugged into a computer. Also, the battery can be replaced by a solar panel. To test my simulator, I took it to the Jump Simulation Center and showed it to several experts. 20% said it was excellent and 72% said it was very good. All trained nurses were able to pass the simulation on the first attempt, while novices took several attempts to pass. This is my invention called the CPR Buddy. It is a patch that you can stick onto a patient who is having cardiac arrest. It can help the user to perform CPR correctly. This LED comes on when you push at the correct rate. This LED comes on when you push at the correct depth, and the last LED will come on when you push at the correct pressure. The beeps that you can hear is the correct rate at which you should push at. Now you will see a demo of my invention working. My biggest challenge was to calculate the depth of compressions. After researching, I found that I could use a MEMS-based accelerometer. So I developed a circuit and an algorithm that consists of an Arduino accelerometer, force-sensitive resistor, piezo buzzer, and LEDs. This curve shows the acceleration of the movement of the chest, so the depth is the area underneath the curve which can be found by integration. I performed an experiment with an accelerometer. The problem was that I wasn't getting instantaneous data. My accelerometer was only giving me a peak acceleration, which happens at approximately 0.125 seconds if the CPR is performed correctly. Since I wasn't getting enough data values, I couldn't numerically integrate it, so instead I used a simple equation to calculate the depth shown here. I calibrated my force-sensitive resistor using a weighing scale. A second good application of my CPR Buddy is to convert a basic low-cost mannequin like the one showed here into a high-fidelity simulator. My CPR Buddy can instantly provide accurate feedback to the trainee and costs less than $35 to manufacture. I performed an experiment with adults not trained in CPR. The graph on your left is without the CPR Buddy, and the graph on your right is with the CPR Buddy attached to the mannequin. Each dot represents one compression. Without the Buddy, the pressure was consistently low, had a high variation of force, and less repetitions were performed. My preliminary study shows that the Buddy does work. I am planning to do a larger study that will fully validate my invention. I conducted a survey where one of the results was very interesting. Everybody who took the survey agreed that my CPR Buddy should be used in every home. I hope that in the future, my CPR simulator and CPR Buddy can save many lives all over the world.